Hello. All right. In today's lesson, lesson 2.8, we're on page 77 of our fourth grade textbook. Our topic today is multiplying using mental math. And so it says, how can you use mental math and properties to help you multiply numbers? All right. Well, let's see. Let's see if we can figure this out together. So, properties of multiplication can make multiplication easier. For instance, there are 4 sections of seats in the Playhouse Theater. Each section has 7 groups of seats. Each group has 25 seats. How many seats are there in the theater? All right, so if we just take our numbers, 4 sections, 7 groups of seats in each section, and in each group there are 25 seats. So we'd have 4 times 7 times 25. Well, one of our properties that we've talked about is the commutative property. And that tells us that our product is the same regardless of the order in which we multiply two numbers. So 4 times 7 is 28. We can do that easily, right? But then 28 times 25, that's kind of difficult, especially since we're still learning to multiply by one digit. So why don't we switch places with the 4 and 25? Because I know that 4 quarters, right? 25, 4 quarters is 100. Okay, so let's switch the order with the 25 and the 7. Giving us a hard time seeing this glare or something. Okay, try that. Okay, so 25 times 7. So all we did was switch the order. And now we're going to multiply 4 times 25 first. And 4 times 25 is 100. And then 7 times 100, oh, that's simple. 7 times 1 is 7. And then there's 2 zeros from the hundreds. So commutative property of multiplication is very useful in multiplying things mentally. This would have been a much more difficult problem if we went 7 times 4 is 28, 28 times 25. Much more difficult for right now. So just switching the order of two numbers helps us do this actually in our head. Right, so let's try some of these. So use mental math and properties. So let's find 6 times 10 times 10. So I see that the 6 times 10 is grouped. And so this is our same problem rewritten. And then we have an equal sign, so both sides are equal to each other. And then I see that on this side, the 10 times 10 is grouped together. Well, this property is often referred to as the grouping property, but its technical name is the associative property. So we're going to use the associative property of multiplication. And that basically says the way in which factors are grouped does not affect the product. So here they're saying, well, you know what? 10 times 10 is easy. Why don't we just make that 100 instead of 60 times 10? Now, I got to tell you, 60 times 10 to me is not that difficult either, because we would multiply 60 times 1, and we know 1 times any number is 60. So 6 times 100 is 600. Now 4 times 9 times 250. So this time, we're going to use a couple properties. First, we're actually going to switch places with the 250 and the product of 4 times 9. So we have 250 times the product of 4 times 9, which is the same as the product of 4 times 9 times 250. So that's the commutative property. That allows us to switch places, or the order in which we multiply. Now you'll notice that, we said 4 times 25 was 100, so 4 times 250 should be fairly simple for us to do too. So let's group the 4 and the 250, and then multiply that by 9. And the associative property allows us to regroup our factors. So 4 times 250, 4 times 25 is 100, and put the 0 from the 250. Now 9 times 1,000, 9,000. 78. Choose the strategy that works best with the numbers in the problems. Okay, so we're going to talk about 4 more strategies, and then we're going to practice those. So use friendly numbers is another example. So I had this 24 times 250, and a lot of us would look at that right now and say, I don't know how to do that. I'm learning how to multiply by 1 digit. What are we doing with this 24? What am I supposed to do with that? Well, let's think of 24. What 2 numbers multiplied together give us 24? And so we're making the 24 more friendly by breaking it into 6 times 4. Okay? And then we can take the 4 and multiply by the 250. So it turns it into a much easier problem for us to do. So 24 times 250, we're going to rewrite as 6 times 4. So the 6 times 4 came from the 24. And then we're still multiplying by 250. So then, what is 4 times 250? Well, we just solved that on the other page, or the other example, and that's 1,000. Now 6 times 1,000, 6,000. So friendly numbers can help us too. Break up a 2-digit factor. Now, here's another one that's great to do if one of the factors is 50. And that method is called halving, or take half of a number and double the other number. So here we can take 16 and divide it evenly by 2. So we're taking half of 16, which is 8. Okay, and 8 times 50 is 400, and then double that. So 2 times 400 is 800. You can also write it this way. 16 times 50 equals 8 times 100. So I took half of 16 and doubled the 50. 8 times 100. I think it's actually easier to see it this way than this extra step here. So it's up to you how you want to write it. Either way works. Okay, and C, use addition. So now we have 4 times 625. Well, that's single digit. And then we have a fairly large 3-digit number. But we can break that up into 4 times the sum of 600 plus 25. And then we can use the distributive property, 4 times 600 plus 4 times 25. 4 times 25 we know is 100. And now here, let's use 4 times 6 as a basic math fact. 4 times 6 is 24. And then we can put the 2 zeros from the hundreds. Now we just add 2,400 plus 100 more, 2,500. And D. Now we haven't talked about this method yet, but it's using the distributive property, but we're subtracting using this method. And so here we're going to think of 5 times 398 as 5 times 400 minus 2. Okay, so 398, that's really close to 400, and multiplying something by 400 is really simple to do. So could I get 398 if I change it to 400? Well, I'd have to subtract 2 to maintain that value of 398. So we have 5 times 398 is the same as 5 times the difference of 400 take away 2. So now applying the distributive property, 5 times 400 minus 5 times 2. So we're going to take the 5 and multiply by both numbers that were involved in our subtraction problem. And 5 times 400 is 2,000, and 5 times 2 is 10. So 2,000 take away 10 is 1,990. Okay. We weren't sure about that. This would be our math, okay? And we know we can take 0 from 0, that's just 0. And then when we get to this one, we can't group that. So we're just going to cross out the 20. We can turn it into a 19 and make that a 10. 1990. All right. So then it says, what property is being used in examples C and D? So again, we took the 4 in this problem and multiplied it by both add-ins. So 4 times 600, 4 times 25, that's the distributive property. And then we also applied it to subtraction by multiplying the one factor by both numbers of the subtraction problem. Okay, so now we're going to move on to number 1. Break apart the factor 112 to find 7 times some number plus 12. I'm sorry, to find 7 times 112 by using mental math and addition. So they want us to use 12. So 12 plus what is 112? That's fairly easy, right? 100. 100 plus 12 is the same as 112. Okay, so now we're going to use the distributive property, right? 7 times 100 plus 7 times 12. 7 times 100, 700. 7 times 12, well, we know 7 times 10 is 70. Plus 2 more 7s would be 14. 70 and 14 is 84. So that's 784. If we start to work on page 79, there's multiple ways for you to solve these. So don't feel like the method that I talk about is the only right way to do it. If there's a different strategy that works for you, use that. Okay. So when I look at this problem, I see 4 times 50 would be an easier problem to do. So what I would do is go 4 times 50 times 6. Okay, so what am I doing? I'm using commutative property to switch the order. Because when there's only multiplication left in a problem, we just multiply left to right. All right, so now 4 times 50 is 200 times 6. 200 times 6 is 1200. Looking at 5 times 420, what is one method we could use to break that apart? What if we did something like this? 400 times 5 plus 5 times 20. 5 times 20. So 400 plus 20 is 420. So we're actually using the distributive property, right? So what I did was rewrote 420 as 400 plus 20. All right, 5 times 400 is 2,000. 5 times 4 is 20. Put the 2 zeros from the 400s. And then 5 times 20 will be 100. Add those together, 2,100. So you could say use addition was that method, or you could even say distributive property. Again, these are just one strategy you can use. You can look through and use a different method if you want, a different strategy. Now 6 times 298. I look here at the 298 and I notice that, you know what, that's really close to 300, right? Well, if it was 6 times 300, that would be a piece of cake to do. So why don't we do that? Let's change it. But I made this number bigger, so I have to take something away from it so it's still equal. 300 take away what is 298? 2, of course. Okay, so now we can use the distributive property by multiplying the 6 by both numbers in the subtraction problem. And here in the middle, we're going to subtract. We need to subtract the partial products, not add them. Here, we added. Here, we're subtracting. Okay, so whatever sign is in the middle here, that's what we're going to do in between our two partial product problems. Okay, and then 6 times 2. So 6 times 3 is 18. Put the 2 zeros from the 300. Minus 12. Okay, 1800 take away 12. We know we can't take 2 from nothing, and we have nothing to borrow from. So let's go ahead and make that 79 and give 10 of those to the ones. 10 take away 2 is 8. 9 take away 1 is 8. 7 take away nothing is 1. So 1788. And so we could say use subtraction distributive property. Number 5, again, this not just one way to solve these. For instance, I could use the distributive property on this problem. I could say 50 times 7 plus 50 times 7. I'm not going to do that, but I could. I'm going to use the half and double method. So what I'm going to do is take half of 14. Half of 14 is 7, and then double the other factor. Okay? So if I take half of one factor and double the other factor, it's an equal expression to what I start with. So I've made this into a very easy problem. 7 times 100, 700. So I'm going to say halving and doubling. 32 times 25. Ooh, I don't like that problem at all. You know what? Let's break up the 32. That's 4 times 8, right? So let's go 4 times 8 times 25. I still don't like that 8 times 25. Let's switch the order of the 8 and the 4. So let's go 8 times 4 times 25. So that's commutative property. That allows us to switch the order, but I started with friendly numbers. I broke up the 32. So 1, friendly numbers, 2, commutative property. All right, so now 4 times 25 is 100. And 8 times 100 is 800. So let's look here. 14 times 25 times 4. Well, why don't we just use the associative property? Because the order of operations says I'm supposed to go left to right. So I'm going to rewrite this and show the associative property. So associative property just tells me how to group the numbers. That's all we're doing. I want to multiply 25 times 4. Because I know that that's an easy problem to do in my head. 4 25s is 100. So what is 14 times 100? Well, 14 times 1 is 14, right? 1 times any number is that number. And I'm going to put the 2 zeros from the 100. So 1,400. Okay, number 8. So you're looking at that. I see 4 times 15 times 25. Oh my goodness, I see the 4 and the 5. I want to switch orders. I want to put the 4 next to the 25. Okay, so that's commutative property. And now my next step would be to group the 4 and the 25. And that's the associative property. So all I did, remember this technically tells me I have to do 15 times 4 first. And I don't want to do that. I want to do the 4 times the 25 first. So I can group that together and make it 15 times 4 times 25. And so that would be 15 times 100. 15 times 1 is 15, put the 2 zeros, so 1500. Now, as I was doing that, as I was explaining that, I realized technically there was a simpler way that we could have done that with only one property. Maybe you saw that and caught that. So let's look here. I switched the 4 and the 15, right? Well, couldn't I switch the 15 and the 25 instead? So let's do this. Now we would multiply 4 times 25 first. And 4 times 25 is 100 times 15, we get 1500. So you could get away with just saying the commutative property. But that gets to what I'm talking about, that there's more than really one strategy for solving these problems. There was nothing wrong with me solving commutative property and associative. But I did technically make it more difficult because I had a second step where I had to group the 4 and the 25. Okay, so I should have just switched the order of the 15 and the 25 to start. All right, now 5 times 198. I like this one because it's really close to 200. So I'm going to change the 198 to 200, and I'm going to take away 2. So 5 times 200 take away 2 is the same as 5 times 200 minus 5 times 2. 5 times 200 is 1,000. Take away 10. Well, what's 100 take away 10? 90, right? So 990 is what we have. Go ahead and show the steps for that. We get 0, and now we have 100 take away 1. 100s take away 1. Let's go ahead and regroup. Let's put 9 and change the 0 tens to 10 tens. 10 tens take away 1 10 is 9, leaving us 990. What did we do? We used subtraction and applied the distributive property. Five times 250. Do we need to make that any simpler? Yeah, we can. Let's do it. Let's go ahead and make it easier. Let's break up 250 and call it 200 plus 50. Now, we love multiplying by zeros. Okay. So that is the same as saying 5 times 200 plus 5 times 50. All right, so 5 times 200 is 1,000. And 5 times 50, 5 times 5 is 25. Put the 0 from the 50. We add that together, 1,250. Okay. What did we do? Well, we used addition. and then we apply the distributive property. All right, number 11. Use a strategy to find the product. Hmm. 16 times 400. Why don't I use the halving method? 16 times 400. And I'm going to take half of 16, which would be 8. I'm going to double the 400. If I double 400, I get 800. 8 times 8 is 64. Put the 2 zeros from the 800, 6,400. So that's one way. You might have come up with a different way to solve that. That would have been fine. Okay, number 12. I see 3 times 31 times 10. Well, what would be easier to multiply? 3 times 31 or 3 times 10? Hopefully you say 3 times 10. So I'm going to use the commutative property. I can use the commutative property to switch the order. And 3 times 10 is 30 times 31. Is that an easy problem? I don't know. I don't know if that's easy. So what should we do? Should we have done something differently to make it easier? Is there a way of breaking up the 31, or is there a way of breaking up the 30 differently? So let's rethink this, because maybe we've made this problem more difficult than it had to be. What if we do 3 times 31 first? We can go 3 times 30 plus 3 times 1 times 10. 3 times 30 is 90. 3 times 1 is 3 times 10. So 93 times 10. That's a little easier to do. 93 times 1 is 93. And put the 0 from the 10. So 930. Number 13. 3 times 199. Oh my goodness, that's so close to 200. And if it was 200, it would just be 3 times 200. Let's do that. That's much easier. So this 3 times 199 is the same as saying 3 times the difference of 200, take away 1. The property says 3 times 200, take away 3 times 1, is the same as 3 times the difference of 200, take away 1. 3 times 200 is 600, take away 3. What is 600 take away 3? I really don't have to do all the subtracting from there. Okay. Even if I have to count backwards, I can. I know 100 take away 3 is 97, but let's say I didn't know that. I just have to back up 3 from 600. So 600, 599, 598, 597. And 3 times 1,021. 14. 3 times 1,021. Well, why don't we use addition for this one too? Why don't we say this is the same as 3 times 1,000 plus 20 plus 1. So all we did was we broke up the 1,021 into expanded form, 1,021, which now is the same as saying 3 times 1,000 plus 3 times 20 plus 3 times 1. 3 times 1,000, 3,000. 3 times 20 is 60, and 3 times 1 is 3. So now let's add up our partial products. We get 3,063. 15. Find the unknown number using mental math. 21 times 40 is 840. Okay, so 21 times 42. Oh, so what's the difference between 21 times 40 and 21 times 42? I see that there's just 2 more sets of 21. Okay, here we had 40 sets of 21, and now we have 42 sets of 21. So all we have to do is add 21 2 more times. So 42 needs to get added to 840. So that number should be 882. And number 16. 9 times 60 equals 540. So 18 times 30. So what did they do here? 18 is twice as much as 19, right? So this number was doubled. 60 and 30. 30 is half of 60. What happens when you half one factor and double the other factor? The expressions are equal. So it's 540. All they did was took half of one, doubled the other. So it's really the same thing. 17. 3,043 people buy tickets at the gate for section N, and 100 people buy tickets at the gate for section L. How much money is collected for section N and section L at the gate? That's a lot of people, right? Let's see. 3,043 people buy tickets at the gate for section N. So here's our arena ticket prices for games. We have 4 sections. We have 3 different plans. We got a full season plan, a 15 game plan, and paying at the gate. Well, this one said at the gate. So we need section N and section L. We know that there's 100 people for one, and there's 3,043 for the other. So 3,043 bought at the gate for section N. Bought at the gate for section N. Section L, there were 100 people that bought tickets at the gate. Okay, so now this one's an easy one to do. 35 times 1 is 35, and put the 2 zeros from the 100. So 35 hundredths. This one's a little more difficult. So what are we going to do to solve this problem? Well, let's see. 3,000 times 25 plus 40 times 25 plus 3 times 25. So what did we do? Or what did I do? I broke up the 3,043 by its place value. I used expanded form. So I'm going to use addition to solve this. And so 3 25s. You can do that in your head. That's not hard. That's the same thing as saying you have 3/4. How much is 3/4? 75. Now put the 3 zeros from the 3,000. Okay, so great. We get 75,000. Now you might look at this one and say, 40 times 25. I don't know how to do that. Sure you do. What's 25 times 4? 4 quarters is 100, right? 4 times 25 is 100, and put the 0 from the 4 tenths. All right, 1,000. Not bad. Plus 3 times 25. We can also do that. That's not bad. All right, so now let's add up our partial products. So we had 76,075 plus, okay, so this is the ones who bought section N tickets, and we have to add the section L tickets, which was 3,500. So 57597. So they collected $79,575 at the gate. Okay. So that wasn't too bad. All right, 18. Tina and 3 of her friends buy the full season plan for section M. Tina and 3 of her friends buy full season plan for section M. If there are 45 games in the full season, how much money do they spend? So I look at M and I find full season. So full season costs 25 tickets. 25 tickets. $25. Okay. And there's going to be 4 of them. So let's break this down. We have 4 people, Tina and her 3 friends. They're going to be paying $25 per game for the full season times 45. Okay, let's make sure we understand where we got these numbers from. The 4 represents the 4 people. The 25 represents the cost of the tickets for each game of the full season. And then the 45 is because they said 45 games for the full season. So 4 times 25, we've had that a couple times already today, is 100. Now 45 times 100. 45 times 1 is 45. The 2 zeros from the 100, 45 hundreds. Well, that makes sense. 45 times 100, 45 hundreds. So $4,500 the 4 friends, the 4 people spent. Number 19. When the full season tickets first went on sale, 2,000 full season tickets sold for section N. 2 weeks after the tickets first went on sale, another 1,500 full season tickets were sold for section N. How much money was spent on full season tickets for section N? And then how much more money was spent when the tickets first went on sale than after the first 2 weeks? We have 2 questions we have to solve here. So first we have 2,000, and they bought those tickets in section N. So 2,000 times 20 for section N when they first went on sale. And then they also have 1,500 for section N, which was 20. So we have 2 problems. We have 2,000 tickets being bought at $20 a ticket, and we also have 1,500 tickets being bought at $20 a ticket. Okay, so 2 times 20,000 is the same as saying 1,000 times 20 plus 1,000 times 20. So 20,000 plus 20,000. So 40,000 in the first couple weeks, or when they first went on sale. Our second problem, 1,500 times 20. So we can break that up into 1,000 times 20 plus 500 times 20. I just wrote them underneath each other. It's the same process as going side by side. So 20 times 1,000 is 20,000. And 500 times 20. 500 times 2 is 1,000. And then put the 0 from the 20, or from the two tens. Add those together, we get 30,000. So together, it was 70,000. So the first part of our question was, how much money was spent on full season tickets for section N in total? 40,000 plus 30,000. So that gives us 70,000. How much more? So now I'm going to subtract, right? How much more means subtract. When they first went on sale, so we have our same numbers here, 40,000, but we're going to subtract 30,000. So 10,000. 10,000 more the second week. And number 20. Find 6 times 407. Show your work and explain why the strategy you chose works best with these factors. 407. What I think I want to do, again, it's up to you. I think I'm going to use addition. I think I'm going to break up the 407 as 6 times 400 plus 7. Okay? So 6 times the sum of 400 plus 7 is the same as 6 times 400 plus 6 times 7. 6 times 400. 6 times 4 is 24. Put the 2 zeros from the 400 plus 42. So I can just put this back together, 24, 42. Okay, and so what did I do? Well, I used addition because I could easily do 6 times 400 plus 6 times 7 mentally. I used addition because I could easily do 6 times 400 plus 6 times 7 mentally. Okay, so that's it for lesson 2.8. And so until tomorrow, may the numbers be in your favor.